hi everyone. Today I'm going to tell you a little bit about data management infrastructure. For me, on my point of view, that's a bunch of researchers doing work, doing studies, experiments, and so on, getting a lot of data. But this raw data is useless if they don't have the tools to make sense of it. And then hopefully having some nice scientific results to share with the world and make science advance. So one of the main challenges for us when we started working on this project was to start from a very, let's say, basic setups of Transmart and the associated tools, which were mostly all-in-one deployments, and shifting to a more distributed architecture. There are several reasons to that. The first one would be that we needed good stability of the application stack. We needed to make it available as much as possible to our users. And we also needed a good level of confidentiality, of course, because this is medical data and you don't want anybody to access it. And you don't also want to lose it. So that's very critical. And we also needed to provide a good performance and be able to scale with the project going on. So to do this, we kind of had to break down Transmart in a nice way. So that's what we started with, basically. This is the Transmart application ecosystem. So you've got the main Transmart application in the middle of this scheme with running on Tomcat. You've got the databases, where the data is actually stored. You've got the R computation engine, to which Transmart uploads a lot of its work. And you of course have a web front end that the users access to. So one of the first issues we faced doing that was that at the beginning, if we had, for instance, data curators trying to load a lot of data on the database backend, while we had users trying to do analysis, for instance, we might have concurrency issues. Maybe because the machine was a bit small at the beginning, but we didn't want to be locked by this fact, so we started taking the database aside and putting the database on a dedicated host. And we realized that we could just put all the databases on this kind of database clusters with specific resources allocated, finely tuned for the database usage, and then all the Transmart instances would just hook up to these database backends and get their data. We also did the same thing for the R computation part, because R can be quite CPU and memory intensive. So we didn't want to have a user running huge loads on R, preventing the other users to have a nice experience as well. So we started creating R computation farms, as we call them. So on the same principle, our Transmart instances offloaded their advanced computation workloads on these cluster farms. And this time, maybe more for security reasons, we also took the web front-end part out of the Transmart stack. For instance, if you have some malicious people on the internet that wants to take down your application, usually they usually attack by the internet. So by doing this, even if they take down the web front end, all the rest of the application stack is still up and running. Putting back up online a web front end is quite easy and quite quick, and it costs us nearly nothing. So we kind of protected all the rest. This one falls down, the service is down for just the time that we need to rebuild the web part and to stop the attacks. Another key point of our success on the infrastructure level was to use the cloud technology. So we use OpenStack because it was already in use at CCIA in 2P3, so we had the expertise on site. And that allows us, through virtualization of services, to be able to scale, because we could easily start new servers, duplicate them if needed. For instance, in a few hours, some of you might attend the training session. So for this training session, we had to create 25 new instances of Transmart. That's quite a lot for our infrastructure, so that's a lot of resources to result in a way. But we are able to provide these resources only for the time of the training, and then reallocate them once the training is done to other use. And of course, cloud technology provides duplication, cloning, and that kind of techniques to build various architectures from basic components. So now I'm going to give you an architecture overview of the Atrix platform as it is today. So you started by piling up hardware. You deploy the OpenStack cloud platform on top of this. So basically from there you've got your resources available for anything you need easily. You've got, of course, the users that want to access them. You start adding up Transmart instances, and what we called the curation instance. So the curation instance, as I said earlier, is the dedicated machine that data curators can access, deploy their own tools, their toolkits and so on. From this machine, they have access to the databases as well. This is the only way to access the databases for data curators. And this package is what we call the Atrix project module. So this is what we duplicated for every project coming into Atrix. Or for instance, if we needed for specific projects to have a production instance that they give to their users, and a development instance that they keep for themselves, so that they can try new data sets, new software, and so on. All these modules rely on the core services. The two main ones being PostgreSQL and the R computation engine. But there are, of course, since it's a complex ecosystem, a lot of other critical systems that users might not be aware of, such as, for instance, the LDAP directory. That's where we store the user information. There is also the network file system, which allows us to provide the same home directory to our users, whichever server they connect to. So that's quite convenient for them. They can find their stuff anywhere on the platform. And we also have other kind of databases, mostly for the websites and so on. As for the Transmart part, there is a front end, a web front end part, which we call the Atrix Gateway. Every user goes through this gateway to access any resources, usually using secure technologies such as HTTPS, which means that the communication is encrypted and authenticated. Some specific set of users, mostly data curators and so on, could access to curation instances through SSH. And we also gave access to some developers to other parts of the system as needed for Transmart. Since it's a complex system, you have also to imagine that most of these components need to talk to each other through various means. So I cannot simply represent it that way, but imagine that it's a complex network. Aside the Transmart parts and the creation instances, we also provide user-oriented services. The first one and the most famous one will be the Atrix website, atrix.org. But we also provide an operations portal. It's a convenient way for our users and especially the project leaders to give access to their team to specific resources on the Atrix platform, to restrict some other parts if needed, and also to access to all the resources of Atrix in an easy way. It gives you a big dashboard and you just have to click and to get access to the applications. On the other hand, we also provide development tools, mostly a GitLab platform, so that the Atrix developers and the community could contribute on software and store their software there. So that's the GitLab platform. And then, as I mentioned, we had along the way new applications coming into Atrix in a framework that we call Atrix Labs. Of course, this complex architecture required a lot of work. And some of these systems were more critical than others. Since we needed to increase their performance and their reliability, we had to find and focus on the most critical systems because this is very both time-consuming and costly to give good performance and reliability to an application. So it can be done on multiple levels. Usually when you start with your single application, you just follow the documentation and you end up with your transport instance, for example. You start backupping things. You don't want to lose the configuration, you don't want to lose that kind of stuff. And then you start adding a replication to the system, for instance, for the databases. Of course, you've got one database node which works well, but if it fails, what happens? So then you start building a second node, and then you've got two nodes working together with the same data. If the first node fails, the application can go to the second to get its data so that you don't have downtime. Then you start adding high availability mechanisms. You start putting front ends that checks the health of your backends, of your databases, for instance, and automatically redirect the user requests without them even noticing that something went wrong. And then, if it's very critical, you add automatic failover or self-healing mechanisms, so that without the subadmin doing anything, it automatically heals up the failing parts. It automatically redirects the requests and so on. So that's very handy for us because we don't have to do anything, and we like that. So the three most critical parts of the Atrix infrastructure that were concerned by these levels of replication and performance were the PostgreSQL database cluster, because that's where we store all the data, so that's very critical to us. We can't afford to lose it. Also the RServe computing cluster and the LDAP directory cluster, because users usually hate to have to re-register to a platform or something like that.
It's a project with a limited lifetime, and I mean you put a lot in place there. So my question would be, also given what we heard from Reinhard earlier, that the University of Luxembourg, the Guillon node, is supposed to be the future infrastructure place for those types of data. How transferable is that?
Actually, we are in close collaboration with people from Luxembourg, and basically we are sharing these famous automation scripts with them so that they can reuse them on their own infrastructure and try to rebuild what they need to from the Atrix infrastructure. I guess they will have to change a few things because every infrastructure can be different. But basically, we just share the scripts. We give them as much documentation as we care to write. Not so much, I guess. But at least we are in contact. We stay in touch, and that's the way we work, I guess.